Welcome back to Applied Mathematics. In this video, I want to talk about the order of operations, which is an agreement amongst all mathematicians that defines what we mean when we write down mathematical expressions. Let me get my head out of the way and I'll go through a little bit of what I mean. In mathematics, an expression is a series of numbers and operations. We say that we evaluate this expression when we perform the operations in order to arrive at a numerical value. And the order of operations, very specifically, is a set of rules that dictates which operation should be performed first. And it may be a little bit counterintuitive at first, but the order of operations only tells us what the next operation is. If you think about it very carefully, you can use it to list out all of the operations in the order that they will be performed. But the rules as stated say do this operation, see what you have next, and then follow the rules again to figure out which operation to do next. There are other notations that have been used historically by various different groups of mathematicians to try to find other ways of conveying this information, but the order of operations agreement seems to be the most elegant solution that we are able to come up with, and mathematicians have been using it for about 300 years now. All right. The order of operations itself, most students are fairly familiar with. It's one of those things that really gets drilled in K-12 mathematics education, but it's also one of those places where if there is an issue, it tends to be here. So I am intentionally going to talk about the order of operations differently than what you may have seen in the past. If you are listening to what I say and realizing that you do things in the exact same way and you're getting the exact same value each time, then you don't have to worry about learning something new. What you know is equally fine. If you are listening to what I say and thinking that you know what another way of explaining the same process, but your way is getting a different value than mine, then chances are that you are misremembering or you have misunderstood in the first place the explanation that you were relying on before. Again, my way is not the only way, but it's intentionally different to try to give you a different perspective if you have had issues in the past. And of course, if it's been a long time since you've even thought about this, all the better. All right. There are 3 steps in the order of operations. And they come down to the complexity of the operation. The simplest operation we have in arithmetic is addition. So we're going to put addition down here at the bottom of the list. We saw previously that addition and subtraction are really the same operation, right? Subtraction is addition in disguise. Whenever you see subtraction, you can rewrite it as addition. So we're going to actually put addition and subtraction together. More complicated than addition is multiplication, right? Multiplication is repeated addition. 3 times 4 means 4 plus 4 plus 4. Multiplication is hiding a lot of addition inside of it. So multiplication goes sooner than addition in the order of operations. And just like with subtraction, we saw previously that multiplication and division are really the same operation. Division is multiplication in disguise. You can always take a division problem and rewrite it as a multiplication problem. Continuing with this theme, though, we have exponents, which are more complicated than multiplication. Exponents are hiding a bunch of multiplication, right? 5 cubed means 5 times 5 times 5. So because exponents are more complicated, they come even earlier. And we're not going to get so far as to see why this is the case. But it turns out that roots are just exponents in disguise. They are a special case of exponents. So once again, they have to go in the same grouping. All right. There is a further step you can take, right? Just like we've taken multiplication as repeated addition, exponents as repeated multiplication, there is another operation. It's called tetration, which is repeated exponents. I have never in my life seen a practical application of tetration, so we're going to pretend it doesn't exist. And we'll stop here with our continuing hierarchy of more complicated operations. Combining with these 3 steps, these 3-tiered hierarchy, are 2 other rules. First, within each step, perform the operations as they appear from left to right. And second, we use grouping symbols to raise the priority of a part of the expression. So the most common grouping symbol is the parenthesis, which tells you do the stuff inside the parenthesis first, and then once you are done with all of the stuff inside the parentheses, then look outside the parentheses and see what else is going on. Fraction bars, absolute value signs, and a couple of other things also function as grouping symbols. Always just saying, do the stuff here first, just worry about what's inside here, and then when you're done with it, go out to the rest of the expression. All right, so a quick example here. (37 minus 48 divided by 6 times 4 plus 15). This is about as simple as an expression can get, and let's work through it step by step and make sure we know what we're doing. The first phase is exponents and roots. There are none in this particular expression, so we're done with that before we even get started. The second phase, the second tier, is multiplication and division. Reading across from left to right, the first time we see multiplication or division is right here. 48 divided by 6 is 8. Everything else comes along for the ride. Continuing here, the next time we see multiplication reading from left to right is right there. 8 times 4 is 32. And once again, everything else comes along for the ride. At this point, we have finished all of the multiplication and division. We are on to addition and subtraction. Reading from left to right, the first time we see addition or subtraction is right here. 37 minus 32 is 5. The rest of the expression comes along for the ride. And then we have just one operation left. 5 plus 15 is 20. As I have said previously in this course, I don't want to ignore the elephant in the room. Calculators exist. I know that you all have a calculator, and we're going to use them quite extensively. And yes, if I type in 37 minus 48, divide by 6 times 4 plus 15, my calculator tells me that the result is 20. I don't have to do any thinking at all. Then why am I bothering? Right. If your calculator can handle the entire expression in one go, why is it worth being able to do it by hand? There's a couple of answers. The first, and I think most important, is that that's not always going to be the case. The order of operations is the foundation of the language of mathematics that we're going to be using throughout the rest of the semester, and you'll continue to use throughout any other mathematics course that you take. Understanding the fundamentals of the language is going to be necessary when we get to more complicated expressions that have variables in them that do not result in numerical solutions. If you don't know what you're doing in the early goings, then you are going to be very lost when things get more complicated. So if you just think about evaluating expressions using the order of operations as a teaching tool, as a stepping stone, as a building block to stuff that gets more exciting later on, that's fine. The second reason that I am not sure how much I trust, but is worth paying attention to, is that if you know the order of operations and you know a couple of rules of estimating, you can get a good idea of what the solution to your expression should be, what the result should be when you evaluate before you do the calculations, right? 37 minus 48 divided by 6 times 4 plus 15. I might round to the nearest 5 and call this 40 minus 50 divided by 5 times 5 plus 15. 50 divided by 5 is 10, 10 times 5 is 50, 40 minus 50 is negative 10 plus 15 is 5. And I got 20, which is definitely not 5, but it's a reasonable ballpark of 5. Consider, on the other hand, had I gone through and said, I think the answer should be somewhere in the area of 5, and my calculator, instead of telling me that the answer was 20, told me that the answer was 5,768. That's the point where I say, wait a second, this doesn't seem right. I go back to my calculator, I type everything in, I realize that I made a typo in my calculator. Calculators are not smart. Calculators are diligent. A calculator will do exactly what you tell it to do, whether or not that's what you want it to do. And the last issue with making sure you understand the order of operations comes down to the rounding issues, accuracy and precision, approximate values. If you are performing operations on approximate values, then there is going to be some rounding that happens based on how well you know the values that you're working with. And that rounding can get kind of messy as you go through the problem. So understanding the basic rules of the order of operations allows you to make sure that you're going to be able to handle those without running into any issues. Because once again, a calculator does not know how to do that. All right. But for right now, let's just continue onward and look at one more expression. I have actually two more that I want to deal with today. The first one involves grouping symbols. 7 plus 3 times the quantity, 18 minus 4 times the quantity, 7 minus 5. Here I have parentheses and square brackets. Parentheses and square brackets are the same kind of grouping symbol. They both tell you to look at what's inside of them before you continue. We use the two different ones just because it makes things look a little bit nicer and a little bit easier to follow when you can see where the parentheses are and where the square brackets are. But the order of operations tells us to look inside of the square brackets, and inside of the square brackets we see parentheses, so before we do anything else, we look inside the parentheses and we're going to do this subtraction, 7 minus 5, which is 2, even though there's multiplication happening further outside of the expression. As always, everything else comes along for the ride. And then inside of our square brackets, we have 18 minus 4 times 2. It's not written using a multiplication dot, but this is multiplication. So that multiplication comes next. Then the subtraction, which finishes up everything that's inside of the square brackets. 18 minus 8 is 10. I didn't dwell on it when we had the parentheses, but I'll repeat it here because it comes up again. I still have square brackets in the expression. But because there's no operation inside the square brackets, they are no longer acting as a grouping symbol. They're now just a divider telling us that 3 and 10 are two different numbers being multiplied together. All right, so we multiply 3 times 10, we get 30. We add 7 plus 30, we get 37. Once more, let me go to my calculator and work through this expression here. I wanted to grab my calculator out on this one because even though, well, my calculator does not have a square bracket key, but a lot of calculators do. The frustrating thing is that a lot of calculators that have a square bracket key do not understand that a square bracket is a grouping symbol. And so even though it's a square bracket where it is written, we have to type it in as a parenthesis. My calculator will understand 3 next to a parenthesis means multiplication. A lot of calculators don't. So it might be worth getting in the habit of explicitly typing in that multiplication, even though it is strictly speaking not necessary, and it's not something that shows up when we write it out by hand. Again, calculators vary. Your calculator might behave differently than mine, but these are some tricks that do tend to come up and do tend to be useful. All right. Let's look at one last example, this time involving a fraction bar. Four times 3 squared over 9 minus 4 squared. Fraction bars are again a grouping symbol. Deal with what's happening in the numerator, deal with what's happening in the denominator, then worry about the division. Although because it nicely divides the problem in half, it's often worth doing the problem in double time. Do one step in the numerator and do one step in the denominator every time you write a new line. If that's confusing to you, you don't have to, but I have never met a student who didn't try to save writing things out every chance they had. So this is a place where it's okay to save space and write out a little bit less. All right, 4 times 9 over 9 minus 16. 4 times 9 is 36. 9 minus 16 is negative 7, and I'm actually going to leave it at that. Maybe I'll put the negative in front and call it negative 36 over 7. My calculator is, oops, I didn't want me, I wanted my calculator. My calculator is able to handle this expression directly. Not all calculators can. So if you have an older model calculator, this is again a place where understanding the order of operations by hand might be important because your calculator just doesn't have the technology necessary to evaluate this. Digital calculators at all have only existed for about 50 years. Digital calculators that have been able to do these sorts of operations have only existed for about 15, and for most of that they were ridiculously expensive. But on my calculator I have a fraction key right here, which gives me a numerator and denominator set up, 4 times 3 squared, and then I'll use my arrow key down up here to get to the denominator and type in 9 minus 4 squared, and the calculator handles the rest. All right, I think that is probably a good place to wrap up here. Gives you a feel for how all of these things work, gives you a chance to practice these things by hand and using a calculator. I want to stress one more time, when you're working with expressions like this, I do want you to try both processes. Work through writing out the expression step by step by hand, and work through punching the expression into your calculator. Make sure you know how your calculator works. If I were to give you a problem like this on an exam and you punched everything into your calculator and got an answer without having to do any work, that would be perfectly fine. But for the homework, as a learning tool, take the time, work these out, make sure you know what you're doing so that when we move onward, you aren't going to get stuck later. For now, as always, thank you for joining me, and I'll see you next time.